So hello everybody, really nice to see all of you here. My name is Matilda Smeds. I'm working as a senior software developer at a company called Matchday, and I'm here to talk about how we are using Rust to build games for the 5 billion fans of football. I'm calling the talk Excitement of Football and Reliability of Rust, but to be honest, I wanted to call it Excitement of Rust and Resilience of Football, because, while Rust is relatively new, the first version of Rust came out in 2015, football is, in one way or another, it's old. There's archaeological evidence that some sort of a ball game was being played in Central and North America 3,000 years ago. And when I look at my son just kicking the ball without knowing that football exists, but he sees the ball and for him it's pure magic to kick it, it's no wonder that football has become what it is today. And we have more than half of the planet watching football, being enthusiastic about football. In this talk, I will first explain a little bit what Matchday is, what I think what sets us apart as a company, how we're different. Then we will look into the game we're building. First, what the experience looks like for the player, and then what the architecture is like on the backend side, because backend is where we use Rust. The client is Unity, built for Android and iOS. And then I also want to discuss some experiences in navigating the ecosystem when developing stuff for backend in Rust, and yeah, that's going to be the talk. Let's go. So Matchday is a company founded 2 years ago, and I think if I had to say just one thing about Matchday is that we have collectible cards with actual FIFPro IP, so we can represent over 60,000 footballers in their name and likeness. And so we have cards. What we have though only the 4,000 maybe better known footballers currently on cards. And I think one point that's kind of interesting, was super interesting for me at least, because I didn't know this, that there is a platform called Y-Scout that serves over 200 different statistics for each footballer in each professional football game. Maybe not in all leagues, but that's a huge amount of statistics. And we actually crunched those numbers and try to simplify it so that we can create casual football management game where the players can actually, have data that's easy to understand. While we are basing our footballer rankings and statistics on their actual performance. So I think that's kind of cool. And here we can see our brand ambassador, Alexia Putellas, whom some of you might know. And then Lionel Messi, whom some of you might know as well, who is actually one of our investors as well. And one thing that's cool about our system is that as we compress those over 200 statistics into these simple stats, we have also calibrated it so that actually, at least in our game, the best female footballers and the best male footballers can play side by side, and you can build your dream team of the best players from both sides. Yeah, so I think that's cool. And our team is super small. Well, not super small, but it's actually super international. It's kind of small, though. We are just 43 people as of last week. We're hiring, though. A shameless plug will come later. And we are spread across 21 countries and 4 continents. We mostly work European and American hours, though. But still, I think that's cool as well. So what about the game? Our game is called Matchday Champions. It's a casual football management game. One key aspect is, of course, the cards. When the player signs up, we give enough cards to start building the team and start playing. And then, of course, we hope that the player might want to buy more cards or swap them or receive them from a friend or something. And then, let's see. So this is our shop experience, more or less. Here we have a player buying a card. And it's messy. This is not coincidence, but messy it is. And now the player has the card in their collection. And then we have the football match experience, which is, it's super casual, it's lightweight, it's colorful. We have wanted to pack the excitement and emotions of football in this experience. So it's a mobile game, right? That's what the client side looks like. What about the backend? So next I will be showing you an architectural diagram. Just take a deep breath, okay? So here on the left side, we have the services and the data storages of the game studio side. Whereas on the right side, we have what we call the platform, which is the marketplace for these cards, and also a couple of external services quite typical for casual mobile gaming backends. And here we have highlighted the core part. Actually, everything that happens in our game goes through the core. So we serve a GraphQL API for the client, and then that resolves the queries for the different services we have in core. They talk together with gRPC, and we have one service for users, another one for footballers, one for squads, one for matches, and one for rewards. So it's we have tried to keep it a little bit modular, a little bit of separations of concerns. That being said, the database is still shared. It's a Postgres database, and some services are like more focused on their tables, whereas others share more freely. But it's been working for us so far. Then we have the streamer, which is a service that takes care of the match experience. We have GraphQL APIs there as well. Actually, on the game studio side, we don't have REST at all for right now, traditional REST API. And then we have WebSocket interface as well, so that the client can send actions during the game, and we can serve maybe responses faster. Hopefully, that is the intention at least. And then, of course, the streamer talks to the core. We fetch data for the match, and we store outcomes for the match and the actions taken during the match there. One thing which I think is really, really cool is how we are using Redis here in the streamer service. So we use a Redis data structure called Redis stream. And in player versus player game mode, you know, the player who contacts the server first will be the primary streamer. And so each of the nodes contacted for the same match will try to create a Redis channel. If it already exists, it means that somebody is already the primary. One node is already the primary, and the other node will have to be the secondary node. And then the secondary node passes player actions to the primary node executes the logic and serves what is being streamed both to the secondary node and to the client through the WebSocket, and to the secondary node through the Redis stream. Then a little bit more simple service is the scheduler, which is just a simple Tokyo server that executes scheduled tasks. And currently the only tasks it's executing are scheduled notifications, and then also managing the daily drills, which are different sets of exercises or tasks or quests, if you may, that the player can complete during the day. And to close the loop, we need to talk about the platform side. So IAP means in-app purchases, which of course are super important in a free-to-play game. So the client integrates with the REST API of the marketplace so that the player can actually buy things, put a card on the marketplace, swap, sell, gift cards. And then when any of these things happen, for instance, a player buys a game, buys a card, on the game studio side, we have to get this information to be able to show the card in the player's collection. So the player buys a card, platform puts an event on the queue, card has been bought. We have this event handler service consuming from the queue, which is SQS in our case. And then that stores the card data on that user's roster or card collection. Okay, so that's the architecture. That's the architecture. Next, we're going to look at the crates we're using. I thought maybe it's interesting, or not. Maybe there are no surprises at all. I don't know. But basically, everything we do is Tokyo. All of our services is Tokyo. We didn't really even look into other options. Tokyo seems to be really established right now, and mostly, with a little bit of a caveat, mostly it's been good building with Tokyo. I will get back to that later. Then our core services are built with Axum, and the gRPC, rather perhaps unsurprisingly again, is Prost and Tonic. Then for the GraphQL APIs, we use Juniper Warp. And here, the reason why we do this is because this combination actually worked. We were able to make Juniper Warp work. I remember trying last fall also with Juniper Axum, and even with the examples, I was not able to make it work in the limited number of hours you have on a commercial software project. So Juniper Warp it is, even though personally I have to say I find Axum more intuitive. For the WebSocket we use Warp, and that has been nice. WebSocket has been easy to use, no complaints about that. And for the database connections, SQLX, of course. Well, it's funny, giving this talk, because I don't know what you are developing with. I'm just talking here what I'm developing with, and somehow making the assumption everybody else is ending up with the same crates. But yeah, again, very established choice. And it's been, again, mostly good developing with SQLX. More on that later. Then for Redis, we use mobc for managing the connections, and Redis Crate for everything else. And in logging metrics department, no surprises there, tracing and metrics, we have Grafana, Prometheus, and CloudWatch in our mix. There are also some other smaller crates we built with that I just wanted to give a small shout out there in the lower part of the slide. So we use Anyhow. We probably even overuse Anyhow, because I see that it's become sort of a standard pattern for us just to do all the errors in Anyhow. After all, we are not building libraries. We have crates in our workspace set up, but thinking about what should be the error types seems complex. So we use Anyhow pretty much for everything, and then push potential retries, logic, and stuff like that back into the API client crates. So the API client crate owns the retry logic. The rest of the service doesn't know what type of an error it was. It doesn't care. It logs it. It either fails the requests or continues as if not much has happened. Then we use .env and env-config. These have been practical, both for setting up the tests and the services. We are recently experimenting with backend for retries. I don't have enough experience on this yet to really say if we like it or not. It's our game is in beta, and it's a recent addition. But we want to build on that, or find something similar or something better. Then, of course, the whole Saturday anything, really, we have a lot of Saturday things in there, and some other crates as well, but I thought this was the most important ones. I think the image credit is not showing, but this is from the Giphy account of Adjuntament da Girona. I wanted to add a little bit of local flavor because I think this football exercise is just so cool, and maybe it explains a little bit why Catalonian and Spanish football players are so good. This is what they do since they're very, very young, I think. Also, this is kind of an preamble for the more practical part where I share about our practical experiences. So first of all, I'm going to talk about Rust and then navigating the ecosystem, and then let's see what else is coming up. So, you know, for me, Rust was a dear hobby long before, or at least that for quite some time before I could even dream about working with Rust. And now I've been working professionally developing Rust full-time since July last year. So of course, it's been an eye-opening experience in many ways. And I have to say, I still love it. I love the I love the rich enums, all the things you can do, how you can how you can package things differently using the rich enums. Result and option are great. I think any statically typed language should have that. Good riddance, null objects. Pattern matching is great. I love that Rust has actually like native functional iterator and collector handling patterns. Those for me are huge pluses. But then of course, you know, I entered thinking that maybe I know already quite a lot of Rust, but it turns out I I didn't. So it's been a learning experience also. First you learn to borrow things, and then at some point you realize that, hey, these lifetimes actually maybe there's something I don't quite get about them. So you need to put in the effort to learn. And when you learn, whole new views and landscapes open, and it's fantastic. Then this has been a huge practical advantage that you can actually refactor without worrying too much about how it's going to go. One thing though, I noticed that I can't refactor in the style I might have refactored in other languages, because Rust complainer will just complain a lot, and it's like an avalanche of complaints, and I can't deal with that. So I kind of found a strategy. We had a case where we roll the match outcome, right? There are probabilities which are affected by the stats and the position of the stars and so on. But we roll the match outcome, and we wanted to do a re-roll as well, and a couple of changes here and there. But this logic was scattered across several services, so I knew I had to refactor before trying to even make those changes. And the only way to make it happen was to actually make a plan beforehand, which probably is a good idea anyway, and then find a strategy. How can I work with the compiler step by step so I can get through this quest? And I found that the best way for me was to move the structs and enums first, go with the data first, and then in the smallest possible pieces, always fixing the references, always compiling, always committing any progress. And then when it came to actual method calls, I would not just change the old method directly, but add a new one beside it. Call the old one old and the new one new, and then see that if that compiles. And then after that, just change one by one the references. And after 5,000, I'm not exaggerating here, 5,000 lines of changed code, everything worked.
Okay.
So I think this is one huge point for us, huge bonus for us, that I see less regressions with Rust than with other languages I've worked with. I come from a .NET project from before that, and though it was a good project in many ways, I see less regressions now. And more than anything, I don't see any more null pointer exceptions, which is fantastic. We have had a couple of panics though. Fortunately, our QA catches them, or we catch them ourselves, or they've never gone to production, not yet, at least. But yeah, it's good. One thing though is that you have to invest quite a bit upfront sometimes, because we have a system where we have types for the DTOs from the external APIs. We have types for the database, the stuff in the database, we have types for protobuf. We have types for GraphQL. And any change you want to make in there, it's going to cascade. So sometimes making these changes can be a bit painful, but it's like an investment you make upfront to then later have code that works most of the time. And yeah, this is one thing I've found in our code reviews, because if I compare this world to the .NET or Java world, in there, it seemed sometimes that classes had like this gravitational pull that would just pull all the logic into the class, and the classes would become very big and huge. And sometimes you would have complex interaction patterns with the base class and the child class and so on, and it could become hard to manage. Whereas in Rust, sometimes it feels like it's the other way around. Sometimes it feels like the struct, even you can implement implementation blocks for structs and enums, and oftentimes you should. But it seems that there's like kind of an opposite pull. Sometimes the data objects are like very bare, and the logic just wants to go to whatever the endpoint flow is. And in our code reviews, we try to fight this, because for maintainability, code readability, a lot of the time, it's still a good thing to keep the data and related logic together. Then about navigating the ecosystem. It's not going to be a sad story. It had a happy ending. But you got to be careful with Tokyo. You have to check if the crates are safe to use with Tokyo. And even if the crate is like great with Tokyo, it could be even made by the people who make Tokyo. You still need to check that the methods you call are safe to call with in async code. So we have burnt our fingers a couple of times with this. One case was, I remember this early prototype of an actor model where each service would be kind of an actor which would manage its data, and we would keep that data in memory, and then it would be flushed to the database every 10 minutes and something, really ambitious thing. And we managed that hot data in memory with a crate called DashMap, which on paper, I see knowing nods here in the front row. On the paper, it seemed good. Yeah. And we read all the warnings on the documentation. It has a lot of warnings. And we thought we were doing everything right. And everything looked good on, locally. But anytime we put the thing under more load, like not even huge load, let's say a couple of concurrent users, the thing would deadlock really fast, and we never understood really why. And then if you go into the issue tracker for DashMap, if you go to Tokyo Discord, you will find that a lot of people are having problems with this crate in particular. So this makes me really think that there are some crates that don't gel well with Tokyo, that you can do absolutely toxic cocktails with it that will kill your application. And the other story, it's more lenient, but it was kind of curious anyway. So the first time I wanted to instrument our services, I chose tracing, right, from Tokyo ecosystem. And of course, innocently enough, I tried to create a span with span entered method.
Yeah.
And it turns out that's not something you do in async code. So locally, everything seemed fine. But then on the server, some spans would not, some log lines would not have spans at all, whereas others might have 4 or 5 spans unrelated to that log line, which made the logs completely usable. And at this moment, I found a nice repository from our host Luca here, called Rust Telemetry Workshop, where he shows how to instrument async code correctly with the instrument macro attribute. And with this small change, the logs were useful again. So, yeah. So you have to search, you have to ask questions, you have to be resourceful. It's not like with .NET where you can go to the Microsoft documentation And most of the things are just served on a big platter, and then you know what's there, and you pick from there. Some of the resources we have used are Discord. I think on Twitter and Mastodon you also can find stuff, but Discord, especially Tokyo Discord, has been useful for me. Even if you don't ask a question, you can just search. Then Rust Reddit is good. Stack Overflow can be useful also at times. There are some obscure old Rust programming forums. If you find a match for your use case, it could be interesting. So you kind of go through a lot of stuff and you try to triangulate and understand what is real and what might work to find the good recipes and avoid the bad recipes, right? So I need to be maybe a little bit faster, but it's hard to have a talk at this time about AI without at this time of human history about programming without mentioning AI. So I think large language models are especially useful for, in the case of Rust, where you have a lot of concepts you need to learn. So you have a patient teacher who can explain you whatever, basically. And as long as you stick to the Rust core language, the advice can be pretty good. Copilot can be useful, except of course, at times it isn't. There are crates where it cannot give anything useful output at all. And then some advice from these AIs can be plain dangerous. I mean, if it's difficult for the human to discern what works well with Tokyo, it's difficult for the LLMs as well. So you still need to read the manual, you still need to read the documentation, and that's not enough. You also need to know if that crate is actually something anybody has had good experiences with in the Tokyo ecosystem if you're building with Tokyo. Also, code conversions are not great, at least not yet. Depending on from where you convert, of course, but maybe in the future we will have LLMs built specifically for Rust or built specifically for Tokyo, and that will be a whole another game. So some takeaways from this talk: pick your crates with care and read the manual when using new methods in async code. Also, I think this is maybe a personal opinion, but when you build a lot of code in short time, things can get messy. And I think Rust offers a fantastic opportunity to avoid that messiness a little bit, push back on the messiness, because you can be refactoring and not worry that much about the outcome. So we have never had a regression due to refactoring. There have been other kinds of regressions occasionally, but not due to refactoring. So a little bit of refactoring, like even small things here and there, super useful. But Rust, if it gives a lot, it also takes something. You have to be willing to invest in yourself and do extensive code reviews. And also sometimes you need to invest even in the ecosystem. If I wanted SQLX to support multiple databases, which I really wish it did, maybe I will need to do it myself. So was that it? No, actually, because we're hiring. So this is the job ad, ask me anything. We do require some Rust experience. The technical task there's a small technical task, but it has to be in Rust. But you don't need to tick all of the boxes. So if the list seems tall, don't worry. If you have some Rust, if you're interested, come chat to me. You can find me also on LinkedIn or matildasmeds.com, my simple webpage. And that's a wrap. Thank you.